Okay, so we're doing our imaginary numbers today in P6. We're just gonna do a few questions on it so that we've got less to do next class. Perfect. If you guys remember I is our imaginary number. Does anyone remember what I is the same thing as? Square root of -1. What's I squared the same thing as? Not -1. So think about if we squared that square root, it would just stay that -1. We'll do other ones later, but this is all we really need to focus on today is I is root -1. I squared is just normal -1. So we're gonna start by doing some basic addition, subtractions, multiplications with our complex numbers. Anytime you have a constant and then a coefficient with an I, we call that a complex number. So complex number is A plus BI. You can write the I term first. I just generally like to write the constant first. So those are all complex numbers. Complex numbers have I's in them. They have imaginary pieces. Okay. However, we're able to treat it basically like how we would treat like a variable when we're doing addition, subtraction, multiplication, etc. So if I do Z1 plus Z2, I'm just adding these two pieces. I've got 3 plus 2I and then plus 4 minus 5I. We combine our like terms, so I can combine 3 and 4 to be 7, and then I can combine 2I and minus 5I to be minus 3I. You guys done some complex numbers before? Perfect. So this should not be brand new stuff. I can also minus them. So I can do 3 plus 2I minus 4 minus 5I. However, I want you to be careful and I want you to put parentheses around that second term. Parentheses around 4 minus 5I. So we make sure that that negative gets to everything, okay? Distribute that negative to the 4, distribute that negative to the 5I. So that's like 3 plus 2I. Minus 4 plus 5I. In that same vein, we're now going to combine like terms. 3 plus -4 is -1, and then 2I plus 5I is plus 7I. Does that seem good so far? All right. Now we're going to do a multiplying problem. So we're just going to take the first one, 3 plus 2I, and we're going to multiply it by 3. Again, if you think of I like a variable, it makes this really pretty simple. You can multiply 3 to the normal 3. You can also multiply 3 by 2I, and we just get 9 plus 6I. Now, in my other class, everyone's like, oh, should we simplify that? Remember, simplifying is basically like undoing what we just did. So you don't want to simplify. If there's no equal sign, do not ever simplify. Just leave it how it is. I wanted you to multiply it by 3. I wanted it by a factor of 3. Right. Now, when I multiply two of my complex numbers, that's where things get a little bit funny. So I'm going to multiply 3 plus 2I times 4 minus 5I. And again, I'm going to treat it like a variable. You can treat I just like a variable. I'm going to multiply, I get 12 minus 15I plus 8I minus 10I squared. Okay. Now, before I move on, just like we mentioned earlier, I squared is the same thing as -1. So that becomes a positive 10. Now, if you can keep everything in a row, you might have already made it positive 10. However, I'm afraid of losing a negative or not keeping my sign correct. So I write it like this, and then I change it to that plus 10. And then now I'm going to combine my like terms. I've got 12 plus 10, which is going to be 22. And then I've got -15 plus 8, which is going to be minus 7I. Okay, we good so far? All right, the last problem is using this division. So we are going to divide them. I've got 3 plus 2I all over 4 minus 5I. Now, the issue here is we have an imaginary number in the denominator, and we cannot have that. Just like you can't have a radical in the denominator, you can't have an I in the denominator. So multiply that. We're going to multiply by what? Not just I, not the reciprocal. 4 plus 5I. Does anyone know what the term for 4 plus 5I is?
Reciprocal.
Not the reciprocal.
Inverse.
not the inverse,
Opposite.
starts with a C. It's called the conjugate. The conjugate, which I think is kind of funny because when we think of conjugate, we think of like Spanish or like a language where you're conjugating verbs. The conjugate is where all you do is just make the number that's in front of I positive or negative. You flip that sign. Everything else stays the same. What that's about to do is get rid of any i's in the denominator and all the i's move to the numerator where they're allowed to be. They're allowed to be up there, okay? Just like we did before, we're gonna FOIL first, outer, inner, last. So in the top, I get 12 plus 15i plus 8i plus 10i squared. And in the bottom, I get 16 plus 20i minus 20i minus 25i squared. You guys okay with that so far? Okay, now I'm gonna combine my like terms in the numerator. I've got, we know that plus 10i squared becomes what? Negative 10. So I've got 12 minus 10, which is gonna be 2. And then I've got 15i plus 8i, which is 23i. That is totally okay in the numerator, that's allowed. Okay, in the denominator, I've got my negative 25i squared becomes a plus 25. So I've got 16 plus 25, which is 41. And then my 20i and my negative 20i cancel, which is what they're supposed to do. If they don't cancel, we have got a problem. At this step, I look and see, does my triangle have any common factors? Do I need to simplify? Nope. I know this might feel ugly, but I actually like this the best because it is a little bit less work. How are we doing with that so far? Doing good? All right, let's keep moving. Let's simplify these radicals, okay? Simplify root negative 16 times root negative 25. First, how can I rewrite root negative 16? 4i, very good. What does that make root negative 25? 5i. Perfect. You guys are doing so good. 4i times 5i is
25 squared.
perfect.
Negative 20.
Perfect.
If you look at your notes.
Okay. Next one's very similar. The only thing is I can't simplify it all the way down to like 4i and 5i. We still have that radical, and that's okay. I do want us to take that negative out front. I want it to be I root 3 times I root 15.
So let's keep thinking about.
Now what do I have to do here? Yeah. When I get I times I get I squared, and then I can multiply root 3 times root 15, I get root 45.
Now,
Or do you just do negative?
We'll just do negative root 45. There's no plus or minus because we didn't add that square root in. You only put in a plus or minus if you did the actual square root. They already had square root, so I didn't add that in. Now I can simplify root 45. 9 and 5, so the 3's will come out. So it's gonna be negative 3 root 5 is my best answer.
On opposite sides of the crisscross. So what I'm looking for is.
Again, we feeling okay? All right, I've got 4 more little problems. Number 3, A, B, and D. We've got just more simplifying, more multiplying, and getting rid of the and using the conjugate to get rid of a denominator. So I'll walk through at least the first 2 with you, but if you feel good, keep solving them and just check in with me as you go to make sure that you're on the right track. So on this first one, before I deal with that conjugate, I am going to distribute, or I'm going to FOIL this out. I'm going to do my numerator, try to get that simplified. So I get 2 plus 4i minus I minus 2i squared, all over 5 plus 2i. Okay. I know that negative 2i squared is the same thing as plus 2. So I'm going to simplify again everything on the top. I've got 2 plus 2, which is going to be 4. And then 4i minus I is going to be plus 3i. And that's still all over 5 plus 2i. At this point, we're going to multiply by our conjugate. What's the conjugate I'm gonna multiply on top and bottom?
Minus
Awesome, 5 minus 2i. Again, we're gonna FOIL. So I've got 20 minus 8i plus 15i minus 6i squared. All over 25 minus 10i plus 10i minus 4i squared. Now I start simplifying. My numerator, that negative 6i squared becomes a plus 6, and then in the bottom, that negative 4i squared becomes a plus 4. Okay, that will help me. So 20 plus 6 is gonna be 26, and then negative 8i plus 15i should be plus 7i. On the bottom, my I should cancel negative 10, positive 10, and I have 25 plus 4, which is 29. And again, I feel lucky because I don't have to do any simplifying. That's as good as it gets. All right, let's look at the next one together. I promise this one's simple, but it looks insane, doesn't it? Let's distribute. So I've got 3 plus 2i root 7 minus 3i root 3 minus 2i squared root 21. Well, can I combine any of these terms to make this a simpler problem? No, why can't we do the 3 and the 2? The 3 has, oh, that's not why.
Didn't you do the 2 on?
With what?
The
The two i's? Nope, because what do they have attached to them? Roots, root 7 and root 21. Can I add them if they have different roots attached to the back? No, so as gross as this looks, this is about as simple as it gets. The only thing I do want to do is just simplify this negative 2i squared down to just plus 2i. So 3 plus 2i root 7 minus 3i root 3 plus 2 root 21 is as good as it gets. All right, there's 2 more on the back side. I think you can try those without me. So go ahead and flip over. I will work them out. I'll tell you when I'm done so you can check your work. But try those last 2. Those are the last 2 problems we're going to do together in class today.
Angle 1 by itself is not constant. So it might not look like
I do have letter C on the board if you need to look at that one. 2 plus.
Oh.
I've got letter C on the board. Is everyone good with letter C? I do need help on letter D though. What's the conjugate that I'm gonna multiply on top and bottom? Negative 3i. Technically, I guess you could just multiply by straight I, Chase, that's fine. I'm gonna multiply by negative 3i, just kind of keep in the pattern of what we've been doing as a conjugate. But if you multiply by I, that will give you the same process as what we're doing. All right, so I've got letter D in. You feeling okay about that? Hi. Reminder, you have no homework. If you want to get ahead, you can start that P6 homework. But we'll finish these notes and do P7 on Monday. Or whenever I see you next. Go ahead and clear up your desk, get out a pencil, get out your calculator. You'll have the rest of the time to complete this quiz. You guys did such a good job taking notes.